Hello, our goal today is to solve quadratic equations by taking square roots. So the first thing that we need to know how to do is to simplify square roots. So for numbers 1, 2, and 3, it's just a quick review on how do we do square roots in general. So number 1, the square root of 81 is 9. The reason that is because if you wanted to break it down and look for number pairs, there's a pair of 9s we can bring out. Or if you automatically know the square root, there's nothing wrong with just writing down the answer too. That's totally fine. For number 2, the square root of 80 is not another one where we can just say the answer. So instead, what we have to do is we have to break down 80. So you're going to figure out what multiplies to get 80. You can use 2 and 40. You can break it down however you want. But whatever numbers you chose, continue to break those down until you only have prime numbers. Then what you're going to do is you're going to look for pairs, and you're going to bring the pairs out in front. So we're going to have one pair of 2's and another pair of 2's, and anything that did not get paired up is left behind. Anything you bring out is going to be multiplied, and anything you left behind is going to be multiplied. So when we do 2 times 2, there's actually going to be a 4 on the outside, and then the square root of 5 is going to be left behind. For number 3, the square root of a negative 4, well, the problem is this negative, because what times itself gives you a negative number? So right now, the square root of negative 4, we're going to say we can't do this. This is no real solution. Okay, so we're going to be relying on this in order to solve quadratic equations by taking square roots. So in order to actually solve quadratic equations by taking square roots, you can't always do this. It's only a specific time you can. There can only be a squared term and a constant, meaning you're going to have something like x squared plus 12 equals 0, or even like x plus 2 squared minus 4 equals 0. You're going to have something being squared and then just a number. You cannot have x squared plus x equals a number. You cannot have that x term. That's the problematic one you cannot solve by using square roots that time. So what we're going to do is get the squared term alone first. You're going to have like x squared equals something, or x plus 2 squared equals something. But whatever is being squared has to be by itself. We're going to do the inverse operation, and we're going to square root both sides. When you square root by both sides, you're going to write x plus or minus whatever that square root is. And you're going to solve or simplify whatever is resulting from your square root then. So let's go ahead and try a couple that are already set up nicely. 4, 5, and 6 here, you'll notice that all of them have this first part. They only have a squared term and a constant. Not only that, they also all have the squared term by itself. They're all x squared equals something. So what we're going to do then is we are going to square root both sides. When we square root, we are undoing the square, so we get just an x. Also, when we square root, we have to write positive or negative, and then we're going to actually take the square root of 49, which is actually 7 in this case. So for this one, we have nothing remaining to solve, so we get x equals positive or negative 7. And if you think about that, if you were to square positive 7, you get 49. And if you were to square negative 7, you also get 49. That's why both positive and negatives work for these problems. So let's take a look at number 5 then. We have x squared by itself. We're going to do the inverse operation and square root to get rid of the square. But we have an issue. We have this negative under this. So looking at this one, when we actually take and square root this, we don't get a real solution. So we're going to write no real solution. There's nothing that we can have giving us a real answer for this. Nothing's going to work. So now we're going to move to number 6. We have x squared by itself. We're going to go ahead and square root both sides. On the left-hand side, the square root and the square undo each other. On the right-hand side, we're going to write plus or minus. And then we have the square root of 160. So that's not something that we know right off the top of our heads. So what we're going to do is we're going to break this down. I'm going to do 16 times 10 and continue to break those down. And I notice that there are a pair of 4's I can take out. So I'm going to leave the plus or minus out in front. Then I'm going to write the 4. And then 2 times 5 is left behind, so 10. So our answer for this is x equals positive and negative 4 root 10. So let's move on and try some now where the x squared is not by itself for number 7. So again, our goal is to get the squared term by itself. So we have to first move the 19 to the other side. We get 5x squared equals 500. Then we still have to get rid of that 5 because the 5 is not being squared, only the x. So we have x squared equals 100. We're going to go ahead and square root both sides. So we have x on one side, and we get plus or minus the square root of 100, which is 10. So our answers for this one is x equals positive 10 and x equals negative 10. And you can always plug those in and check your answer and see if this works. Now, number 8 is different because this one has the squared term by itself. It's just the squared term is not one term anymore. It's a binomial. So what we're going to do is we are going to start off by square rooting because the squared term is by itself. We get x minus 3 because, again, the square root and the square undo each other. We're just left with whatever was being squared. On the right-hand side, we get positive and negative. And we're going to take 20 and we're going to break it down looking for our number pairs again. So 20 has a number pair. There's 2 2's in there we're going to take out. Whatever didn't get paired up is left behind. So now we have an interesting equation. We have x minus 3 equals positive and negative 2 root 5. Our whole goal here is still to get x by itself. So we're going to add 3 to the other side. But the problem is we cannot combine 3 and 2 root 5 together. They're not alike. So we can't combine them. So what we're going to do is we're going to write the 3 out in front. And we're going to leave it as positive and negative 2 root 5. So our two solutions technically are 3 plus 2 root 5 and 3 minus 2 root 5. Those would be decimal answers, but we're going to leave it written as x equals 3 plus and minus 2 root 5. So that's going to happen when you have something that's a radical and a nice number being added together, or a rational and an irrational. You're going to leave it with the rational part first, plus and minus the irrational part second. So let's go ahead and try a couple more now that are, again, not as nice as the first couple we started with. So for both of these, our goal is to get the squared term alone first. So for number 9, we're going to subtract 1. And then we're going to divide by 2 because notice the 2 is not being squared, just the x minus 7. Now the squared part is alone, so we're going to undo the square by doing the square root. So the square root and the square undo each other. We're just left with x minus 7. On the right-hand side, the square root of 36 is 6, but we have to have the plus and the minus. Then what we're going to do is we're going to add 7 to both sides. And we're going to write this one like we wrote number 8. We're going to write the 7 out in front, plus and minus 6. Now this one's a little bit different because 7 and 6 are both rational. We actually can add and subtract them. So what we're going to actually do is we're going to think about 7 plus 6 and 7 minus 6. So if we do 7 plus 6, we end up with 13. If we do 7 minus 6, we end up with 1. And so what's happening here is we actually get two rational answers. We get x equals 13 and x equals 1. So for this next one here, we're going to start off the same way. We're going to get the squared part alone first by adding 5. We get 3 times x minus 5 squared equals 36. We're going to divide by 3. We get x minus 5 squared equals 12. We're going to go ahead, now the squared part is by itself. We're going to undo the square by square rooting, and we're just left with whatever was being squared, which in this case was x minus 5, equals plus or minus. The square root of 12 is not something that we know off the top of our heads, so we're going to break it down and bring out the number pairs and leave behind anything that's not paired up. Then we're going to move over the 5 to the other side, and so we get 5 plus and minus 2 root 3. Those cannot be combined because we have a rational and an irrational. So our final answer for this one is x equals 5 plus and minus 2 root 3. So there are practice problems for you to try. I will go through them, but I'm going to ask you to pause your video and try them yourself first, and then I can go over them. Okay, so go ahead and hit pause now. Okay, so after trying these practice problems, let's go ahead and see what we get. We're going to go ahead and square root both sides for number 11, and we're going to write plus or minus. 225 is a perfect square, so our two solutions are positive and negative 15. Number 12, we're going to go ahead and square root both sides, and as you did that, hopefully you realize we can't take the square root of that negative, so there's no real solution for this. For number 13, after you tried it, we're going to go ahead and add 10. We're going to divide by 5. And then we're going to square root both sides. We're going to get positive and negative. The square root of 34 is not going to simplify, so it just is the square root of 34. Okay, 14, we're going to go ahead and subtract 5. We're going to divide by negative 2. When we divided, it actually became a positive, which is good news for us, because we are going to square root both sides. 63, we can break down. There's a pair of 3s that come out, and a 7 that remains inside. We're going to move the positive 3 to the other side, and we get negative 3 plus and minus 3 root 7. Okay, for number 15, we got to get rid of that 1/2 because it's not being squared. We get x minus 4 squared equals 100. We're going to then square root both sides. We get x minus 4 equals positive and negative 10. We move the 4 to the other side, and we get 4 plus 10 and 4 minus 10. And so we're going to go ahead and figure out 4 plus 10 is 14. 4 minus 10 is negative 6. So we end up with two answers, x equals 14 and x equals negative 6. I hope this helped. Have a great day.